Hey, hi, this is Joel over here, and this is the first video of our NLP course. And NLP, in the sense, it's called Natural Language Processing. So, what is natural language processing? We have to process the natural language which we, the humans, speak, and we have to make the computers to understand the language which humans speaking. Basically, computers understands zeros and ones, and we have to make computers understands the language which we speak into zeros and ones and make them to interpret and compute and gives us a proper results. So natural language refers to how people communicate with one another, and humans regularly communicate in many different languages like English or any other regional languages. So those languages should be converted into ones and zeros such that computers can understand and they can react intelligently to communicate to the humans. So this is called the overview of natural language processing. Natural language processing is a subset of artificial intelligence that enables machines to understand and communicate natural language like humans does. It also involves using algorithms and techniques such as machine learning, deep learning, and text analytics to interpret and analyze natural language content from audio recordings, document, images, or other sources. And applications of natural language processing. So natural language processing, so NLP can be used for sentiment analysis, chatbots, online searches, document analysis, smart assistants, and automatic summarization. And there are various kinds of applications for NLP. Let's see like one by one in later. And Google Translation is also one kind of NLP application. Microsoft Copilot, Bing in NLP, and all these are like kind of major applications that we are using in day-to-day life with NLP. Computational linguistics. So, what exactly is computational linguistics? It is the field at the intersection of language and computer science. In simpler terms, it's all about teaching computers to understand, interpret, and even generate human languages. It combines linguistic theory with machine learning and programming to create tools like chatbots, speech recognition system, language translators, virtual assistants like Siri or Alexa, and even grammar checkers like Grammarly. It's the brain power behind how machines make sense of human and communicate. So why it matters? Computational linguistics helps solve real world problems like breaking language barriers, enabling voice to text technology, and even analyzing social media trends. It's also key in developing natural language processing, which lets AI system reads and responds like humans does. Without computational linguistics, modern AI would have no clue what we are saying or typing. And history of NLP. So NLP is basically got generated in 1950 by a famous person called Alan Turing. And the first article for NLP has been titled called Intelligence, and which has been proposed now called as Turing test. And based on the famous experiment, which is like Georgetown experiment, which happened in 1954, it fully involved in automating translations of more than 60 Russian sentences into English. And in 1980s, most of the NLP systems were being based on complex sets of handwritten rules, which doesn't have any deep learning or machine learning. It's full of handwritten rules. And in 2010, deep neural network has been initiated, and machine learning methods became widespread in natural language processing. And this is a short history of NLP. Let's understand the processing stages in NLP. We have 7 processing stages in NLP, and they are phonological analysis, lexical analysis, syntactic analysis, semantic analysis, discourse integration, pragmatic analysis. So let's go one by one. What is phonological analysis? This is all about sounds. When we speak, we produce various sounds like phonemes. Phonological analysis is used especially in speech recognition system, like when you ask your phone to call someone or search something using voice. Here, the computer breaks down your speech into phonemes and tries to understand how those sounds combine to form words. So basically, it answers what sounds did the person just make. And the second is morphological, or you can say it is as lexical analysis. So, morphological analysis, which is also called as lexical, because it step focuses on structure of words. It splits sentence into individual words, identifies the root forms and checks for morphemes, and the smallest units of meaning in a language. For example, the word unbelievable has three morphemes, which is un, believe, and able. At this stage, the system also looks up words in the lexicon or vocabulary to see if they are valid. It's like asking, is this a real word? What does it mean? What part of speech is it? So these aspects comes under the topic called morphological or lexical analysis. And the third we have syntactic analysis. So syntactic analysis is also called parsing. This stage checks the grammar of the sentence. It builds a tree-like structure to show how words relate to each other. For example, in the sentence, the cat sat on the mat. The system identifies the subject, the cat, the verb sat, and the object on the mat. If something is grammatically incorrect, like sat the cat mat on, the syntactic analysis would flag it as a problem. It's all about making sure that sentence structure is correct. Semantic analysis. So now the system understands the words and the grammars. It tries to understand the meaning behind the sentence. Semantic analysis looks at the context and relationships between the words. For example, she unlocked the door with a key. It understands that the key is a tool used to unlock something. It also detects ambiguity, like a sentence which we say, I saw the man with the telescope. Did I see the man using a telescope? Or did the man have a telescope? Semantic analysis helps to figure that sometimes with the help of the next step, which is discourse integration. This is where the machine looks beyond just one sentence. It considers context across multiple sentences to maintain coherence. For example, John went to the store. He bought some apples. Discourse integration helps the system understand that he refers to John. This step is essential for chatbots, personal assistants, and language models to carry on meaningful multi-tone conversations. Finally, we have pragmatic analysis. This step focuses on the intent behind the words because sometimes the literal meaning isn't enough. For example, if someone says, can you open the window? They are probably not asking if you are physically capable. They are politely asking you to open it. Pragmatic analysis understands these tone, sarcasm, commands, and even hidden meanings based on the situation. It answers what does the speakers really mean. This is especially important for AI systems to interpret human emotions, politeness, commands, and real world knowledge. So, in summary, phonological analysis is used for recognizing sounds, lexical analysis, identifying words and meanings, syntactic analysis, checking grammar structure, semantic analysis, understanding the meaning, discourse integration, maintaining context across sentences, and pragmatic analysis, interpreting intent and implied meaning. Each step builds on the previous one, forming the backbone of how machines understand human language. So next time you talk to Siri or Alexa, just remember they are running through all these steps in milliseconds to reply to you.